السلام عليكم. أشكر لكم حضوركم اليوم. أنا عمر العثمان من نادي الهندسة جامعة اليمامة. برحب اليوم بضيفنا المهندس حسين أبو شيخة. I would like to welcome Engineer Hussein Abu Sheikha, the head of strategic engineering in Hiliti, who's going to talk about the fundamental of passive fire protection, which is a very important role of every type of engineering, especially for us here in relation to our fields of study. Thank you so much.
Thank you. Allah يعطيكم العافية. Okay, good afternoon. As I understood, you need the lecture to be in pure English, yes? So we are all Arabic and English speaking here. So thank you for the introduction. Thank you, Dr. Hassa, for this opportunity that you are giving us as a Hiliti company. I believe today's topic is really important for us. It's important for us on all levels. And I believe we have senior students in engineering. So for me as a structural engineer, graduated in 1985 with, let's say, massive experience we have, I believe we have a lot of homework to do. And not only in Saudi Arabia, it's all over. So when we talk about buildings, we talk about structural and non-structural applications. So having the structural applications, I think it's taking the main care and the 100% care from all of us as engineers, everywhere. I'm not talking about Saudi Arabia in specific. And why is that? Because we think as engineers, the whole building is only concrete, reinforced concrete, foundations, slabs, and columns, beams. And we forget, we ignore the other part of the building, which has to do with different trades, such as subcontractors, electrical, mechanical, plumbing, steel and metal, and we forget about glass contractors and glazing and facade. So coming to the important topic by safety, I believe we are all aligned today as engineers, and hopefully you graduate soon, that safety is key. So working and living without safety is a dead end. And you cannot compromise on safety. So what happens, the accidents do hurt, but safety never do. And I believe you gamble with your life when you bet on safety. So this is really important about safety. What does this mean for us in Saudi Arabia? So we are a Hiliti company, just to give you a brief about our company, where we come from. We've been in Saudi Arabia since 1965. 2011 onward, we are directly operating from Switzerland. So we are a Swiss company. So we are coming from a country in Switzerland, it's called Liechtenstein. Liechtenstein is coming as a small country in between Germany, Austria, and Switzerland. So in 30 minutes, you can go over 3 countries in Europe, in the Alp mountains. This is where we come from. So the company was founded in 1941. We are main partnership with construction, industry, everywhere in the world. And we are operating in the whole world. We almost have 27,000 employees all over Hiliti. And we work in 128 countries, including Saudi Arabia. So in Saudi Arabia, we are covering almost 1,200 kilometers north to south and 1,000 kilometers east to west. Having almost a platinum record in Saudization, so this is a demand for us, and this is our goal why we are doing some strategic engineering in Saudi Arabia. We are having a program that we carried with the Saudi Council of Engineering for the last 1.5 months. So we took the part in East, in Dammam, and in Riyadh, and in Jeddah. Next year, we will have also to add Mecca on it. So we are taking the new graduates for almost 1 full intensive week of training on the fundamentals of fire stopping and the fastening technology. So in Saudi Arabia, we are servicing Kingdom via 13 branches in Saudi Arabia. So in brief, we care a lot about research and development. So in 2016, we had a record. We are spending more than 283 million Swiss francs on research and development. So almost on a yearly basis, we spend more than 6% out of our sales turnover on research and development. So research and development for us, it's all engineers. So invention and modifications can never stop. That's why we urge you as engineering, once you graduate, do not stop. It doesn't mean that when you graduate, you became the engineer. When you graduate, you become an engineer, but to be the real engineer, as distinguished, to differentiate yourselves, you need to update yourself on a daily basis. I graduated in 1985 from the States, and I'm a member on almost 20 groups all over the world. So I update my information on a daily basis. So the thing about Hilti, every year we develop about 165 new products. So mainly we launch about 60 products per year as 100%. And we talk about almost more than 100 million customers per year we make. More than 230,000 daily contacts all over the world via our multi-channels. And end of the day, we have more than 73% of our employees, they recommend the Hilti for others. 77% of our management are developed internally. Just to give you an idea what we do, what type of business we have in briefs, so that I'm talking about introduction of the company, then we'll go to the subject. We talk about the fastening technology. We spoke about electrical, mechanical, plumbing, steel and metal applications, and non-structural. So talking about the false ceiling as you see upstairs, this is non-structural application. How did we connect it to the main concrete? So God forbids if some external earthquake or shock happens, it's very important how we fasten things. So Hilti is pioneer on this. Electrical tools, this is very well known. And direct fastening, we also have what we call it direct fastening technology, where you shoot the nail and the stud into concrete or steel within 10 seconds and you make the fastening reliable. We talk about the fire stopping material, which we will talk about today in depth. And we have the diamond sewing, meaning that any concrete element in demolition as reinforced concrete, for us as structural engineers and all engineers, we need zero vibration in a building. Meaning that we do not need to disturb the foundation or anything, so using the diamond coring machine. Measuring systems, we are talking about surveying equipments as laser tools. This is the latest technology. And we talk about the mechanical, electrical, plumbing support system, which depends on a special steel profile that we manufacture to avoid the traditional method. This is where we started in Jeddah as Saudi Council of Engineers for 5 days. So we trained 50 engineers, 5 intensive days. And we did not add Mahmoud, the one in Riyadh and the one in Dammam. And just to give you an idea, the projects that we incorporated our technology in, we talk about King Abdulaziz International Airport. This is a 29 billion Saudi Riyal project. We almost provided all systems to this project. Jabal Umar in Mecca, Haramain expansion also as a project, and Tadawul Tower in Riyadh, King Abdullah Financial District in Riyadh, KFD, you all know it, and I believe it will continue. It started now. So Samsung is one of the companies that they started to work now. And we talk about King Khalid International Airport, Terminal 5. So these projects, we provided the fire stopping material to it. Sadara, of course, as oil and gas, international technology, and King Abdullah, King Khalid University in Abha, and Burj Rafal, Korea, of course. Most of the key mega projects in Saudi Arabia, we used our fire stopping material in it. This is a project in Riyadh. It's a very nice story where it's designed by Zaha Hadid. As you see, it's irregular steel structure, and it needed all technology to integrate the fire stopping material in as safety, and all mechanical, electrical, plumbing support systems as services where we as Hiliti made all the engineering work for them. So we start now on our main subject for today. For your information, we took some statistics from the United States. So what do you think, every how much they receive, let's say, calls the civil defense in the state that there is a fire in the states? So the answer is there, it's every 23 seconds. So imagine in the United States, civil defense is receiving every 23 seconds a call, there is a fire. So we are talking about 11 billion plus US dollars as investment loss per year. And we talk about there is a missing zero here. More than almost 30,000 people either fully injured or killed in the accidents. So what happens normally in a fire? This is our understanding that the fire, when it happens, the smoke will come up, and heat, of course, will build up, and low visibility, so you cannot see in front of you in case of fire. So what we have at the moment, as mechanical engineers, our design, we have the sprinklers, and we have the fire extinguishers, and we have the civil defense. Now my question to you, is this enough? Now we are sitting in a big hall at the moment, and we have a big question, is it really safe to stay here in case of fire? So what is the human behavior when you hear the fire alarm? Do you immediately move and escape? Okay.
No, get down.
Thank you. So we have different opinions. For me, maybe I stay for 10 minutes. Oh, what's happening, guys? Maybe I send somebody, check what's happening. But by then, guys, it's too late. If we have the three main, let's say, things that are produced by fire, heat and smoke, and we are talking about the third element, low visibility. So which one is the killing factor for you? Smoke, thank you. So smoke is the main killing factor. Heat is something where you can control. Some statistics from the National Fire Protection Association, we talk about 75% of people who die, it's because of smoke. 100%. 47 people who survived, 47%, they couldn't see more than almost 3 meters in front of them. So this is what causes also low visibility. 57% of the people who die, they do not die in the place of fire. So if you have a multi-story building and the fire in the first floor, people, the 57% die in the 10th, 11th, and so on. And the smoke travels more than 36 to 128 meters per minute. An example, like King Fahd Stadium in Riyadh. 10 minutes, the stadium can be filled with smoke only, with such statistics. What you see in front of you is a nice picture for a tower we have in the UK. It's a Greenfield tower. And this is before the accident. Look what's happening after the accident. Unfortunately, this was last year, and people who died, 79 people, are all immigrants, Muslims from the Middle East, in London. We have more than 80 inhabitants injured, and also $9 million US to bring the tower almost back to where it is. So we are talking about two things. We are talking about saving lives, and we are talking about saving assets. Is it really your concern as engineers today to do this? It's 100%, and proactively, it's your job. So this is our sole responsibility to do proactive job in terms of specifications, in terms of design, and in terms of knowledge and understanding to our Saudi building code. And I believe Saudi building code just started, and I'm glad to see that there is enforcement on it in Kingdom. Before, there is no enforcement. It's totally under the municipality and under the civil defense. Another sad story, unfortunately, it happened in Kingdom of Saudi Arabia, which is Jazan Hospital last year. And unfortunately, the accident happened again just a few weeks back. The question is, what happened and what did we do about it? So this is the intensive care unit picture, as you see here. Look at it. 31 people died. And we have more than 107 injured. We will come later on, why did this fire happen? Of course, fire can happen, but what did we do to prevent the lives and the assets? So our main protection, our main goal here is to protect the people, to protect the assets, and to make sure that we understand the codes and regulations. And I don't know, Dr. Hassa, how far are we on codes and regulations in the university here? Is it part of the, are we teaching this? Okay, but are you aware of the updates that's happening at the moment, just up to last week, that yes, they printed the last edition and they made awareness with Saudi Council of Engineers. So I would really urge you to invite somebody from the Saudi Building Code. I can give you a name where he can come and introduce it probably in a workshop for your engineers. We have three main elements to take care of. We talked about at the beginning, yes? Is it enough to have only the firefighters and the fire extinguishers? No, it's not enough, so we have to have the third element, which is the compartmentation, the containment of fire. So we talked about electrical, mechanical, plumbing, and civil applications like expansion joints. In such a wall where we have adjacent building coming to it, we have many penetrations going through. Maybe it's a cable, it's a duct, it's a cable tray. We need to make sure that if a fire breaks in the adjacent room, it doesn't come to this room. So we have to wrap and we have to fill these gaps and penetration with a special fire stopping material. This is what we talk about containment, and we talk about a chemical product that will react under fire and will protect the whole building from smoke, fire, and water also. We will talk about why water for minimum integrity of 2 or 3 or 4 hours. Why? To make a safe path for you and for us just to escape until civil defense comes. So this is the comparison between the active system, what we have. We are talking about the active system consists of sprinklers, suppression system, and firefighting with civil defense that control only the movement of smoke and fire. Can they control it? You see probably in Dubai, many towers are on fire. You see everywhere, I believe 2 months back, we had one of the Ministry of Interior buildings in Dammam, totally burned. So they couldn't control the fire. The second solution we have is to protect proactively via compartmentation, as you see here, by a passive fire rated system, which we will take in depth today. So what does this mean for us as engineers? You know, we talk about electrical engineers, mechanical, and we talk about civil. So coming to a building where we design, we make all the layouts. Mechanical engineer comes make the design for, let's say, ducts, for piping, and cable trays for electrical. And we need a health and safety engineer to come and say, okay guys, what about the fire stopping material? What about, let's say, the main safety of the building? How many health and safety engineers we have? Or we are, let's say, educating in a bachelor degree. Do we have in Yamama? Are you sure? Okay. Well, I think this is very important, and we see why. Unfortunately, in Riyadh, as 30 years in Riyadh, now the civil defense with Saudi Building Code started to, let's say, to identify some health and safety engineers, health and safety consultants. And sorry, my friend over there, they are very minimum, because we didn't start early on it. We have, but not enough. So over here, the health and safety engineer will take the layout of the drawings of the building and will start making compartmentation. So the red lines you see here in a vertical, let's say, this means that the health and safety engineer, he said, and he came and they said, if a fire breaks out in this zone, this is the safe path for my people. I want to make sure that smoke, fire, and water will not break through. Not from here, not from here. And this is a layout where we see the rooms and the corridor, it's 100% seals. So we talk about this well. And in a horizontal, we make sure that between a floor to floor, that the fire, smoke, and water will not break through. So this means we contain the fire in the right place. So this is a more detail, how we have it. This is how the drawings will come up. And this is what we talk about compartmentation. It's only a health and safety engineer who will do this. Normally the fire, we are talking about pressure, the tendency of fire, how the fire starts, the build-up of pressure, where it goes, and the weak points in a room or in a building, how it develops. So having this simulation, this is what we see. High pressure build up, so lots of smoke comes up. If we have, and maybe this room is not the right, let's say, example to use, maybe in the main building of the university, you will see some partitions, dry walls, as interior finishing. The dry walls are not connected to the roof. So the false ceiling only takes the dry wall, and on the top of it, it's just an open area on the whole floor, on the whole building. And this is a weak point. So this is a part of the applications we are talking about. This is a building, what you see. And we need this wall to be 100% fire rated. So what does this mean? It means that the concrete itself, or a drywall of gypsum boards, has to be designed as fire rated. So I believe as engineers, we design our concrete as minimum 2 hours fire rated, as concrete. We talk about any penetrations that comes in, either cable tray or piping or ducts. We have to make sure that this penetration, where the penetrant is passing, is 100% sealed with the proper material. So end of the day, in case a fire breaks in here or in the other room, we make sure that this room or that room stays safe 100% from all inhabitants, let's say as people or anybody. This is a video to show you the case of, let's say, spread of smoke and fire.
Typically, 5 minutes is all you get. Fire, and especially smoke, spread through a building much faster than most people think. Every year, about 3.8 million fires occur worldwide. While damage to assets is in the billions, the yearly death toll amounts to 45,000 persons. Much of this could have been prevented if correctly installed fire protection had been in place.
Architects, planners, engineers, and building owners are responsible for effective fire protection. Oftentimes, they do not realize that fire stop is not an option. It's a clear legal requirement, and negligence or improper execution is a violation of the law. Nearly 60% of fire deaths are not in the room of the fire's origin, and 3/4 of all fire deaths are caused by smoke. When there are through penetrations in walls and floors, toxic smoke easily spreads to adjacent rooms. The keys to effective fire protection are both active protection, such as detectors and sprinklers, but also passive protection. Passive means that penetrations in walls and floors have been sealed with approved fire stop products. This principle is called compartmentation. When installed correctly, fire and smoke won't be able to spread from one compartment to another. This allows for safe evacuation of people and protects valuable assets. The thing about compartmentation and fire protection is it's only as good as the products you use. You know, one always thinks that accidents only happen to other people. That's a false conclusion. It is the responsibility of architects, planners, engineers, and building owners to protect lives and assets by effective and well-designed compartmentation. Hiliti offers innovative and legally compliant, internationally approved solutions. We recommend Hiliti to be on the safe side.
How many architects do we have in this room? Future architects, hands up, more. Wow, this is great. So the Rolls-Royce I'm taking the Rolls-Royce as, okay, the top authority when we talk about master specifications. It comes from architects. So the enforcement of the specification we are talking about is the architect. And this is as per code. When we have an architect approval in a project such King Abdullah Financial District, where we have around 60, 80 towers, this is the 100% approval for the whole project, not for one building. That's why the responsibility of architects is really important. So I really encourage you over now and take the responsibility for you as to start getting the knowledge and education how to do things in the future. Maybe you will become a consultant, maybe you become a site engineer, a material engineer, or whatever your responsibility is. So you need to enforce this. So talking about the building code, we are talking about two main applications, the through penetrations and the expansion joints. And when we talk about fire rating, we talk about something, it's called the system. So we do not talk about a product over here. And we do not, in terms of safety, we do not say go bring this product from Hiliti to make sure that this is 100% fire rated. We talk about a liable system. It is as per standards, and we follow up standards. This is not something where we can, sorry to say it, we use this slang language saying in Riyadh. It's not something where we can cook in Batha. This is something where it's highly engineered. This is something where we need to design it 100% as per regulations, as per standards, meaning zero tolerance. And what's killing us, unfortunately, since I am almost 37 years as an engineer, is engineers, they give tolerance in what they do. Yeah, يلا معلش ماشي, let's do this, yeah? بيمشي الحال. No, ما بيمشي الحال, and it doesn't work. So we need to do 100%. We need to listen to the experts. We need to look at the approved, let's say, laboratories in Saudi Arabia, and we need to follow. That's why we talk about a system, and we will come up why is a system. By the way, Saudi Arabia is following in the fire stopping material the US standard, and we will come why it's the best. So we are talking about the UL. You see the word UL here. It refers to the underwriter's laboratory in the States. Now, also it's coming as commercially, you know, everybody's looking for money. They opened a branch in Europe, and they opened a branch also in the Middle East. It doesn't mean that a UL certificate in Europe, it's the same one in the States, no. The one in Europe, it follows the European code. And the one in the State, it follows the US code. So we need the one in the US as per ASTM, not as per the Euro code. Any questions up to now? Please do. Okay? So this is what we talk about. We have the products, yeah? And end of the day, we take these products and we make a system out of it. And the system is not up to me and not up to you because we do not have the real expertise in it after trials and experiences. It's as per UL. So this is a UL certificate. In more details, the normal picture over here, and this is why we are here today for you as students, is as we said, we want to work proactively. Proactively means in the design stage, we look at the applications we have. Let's say the mechanical engineer will come to ducts and he will see the sizes of ducts, make an Excel sheet. Then he goes to a company like Hiliti, they will recommend a product for him. But before you make your design 100%, your design has to be as per UL. So if you have a cable tray as 30 centimeters, then the opening size must fit as per UL. Otherwise, it's no way. Then at the end, we have around 6,800 UL certificates in the system for Hiliti, and it's under www.ul.com, where you can be as an architect, as a civil engineer, along with our specification engineers in Hiliti. They can highlight to you the whole UL as fits in your project. Then you can put it in the bill of quantities, and it goes for tendering. And unfortunately now, talking about tendering projects in Saudi Arabia, Maybe around 5% of projects tendered in Saudi Arabia, they have such specs. The rest, they don't have. What does this mean? It means that the tender documents went through without bill of quantities to have a bid on fire stopping. So a contractor will not put something he's not paid for. So whose mistake it is? It's the consultant mistake who designed this project without fire stopping material. That's why we have to forget about, let's say, the commercial subject and how much it costs, and we go on safety. This is the UL code, and we are talking about Saudi Arabia is following the ASTM as per International Building Code. So in 2007, Allah yarhamu al-Malik Abdullah, we started, I believe, the first edition, and it was from the top 20 university committees in Saudi Arabia. And I believe for the last 2 years, the Saudi Building Code Committee did a great job because I'm very close to them personally. And we are doing as Hiliti also some workshops with the government departments, all clients, all ministries, with Saudi Building Code and the Saudi Engineering Society, the Saudi Council. So they really did a great job, and they did a great job where now they need to implement and enforce, so they need engineers, they need consultants. Probably they are sourcing now from outside, from the States and from Europe, and that's why we urge all of our young engineers to go in this path and go into health and safety as architects and so on. So all over the world, we talk about Saudi Arabia, 100% in the safety, we are talking about UL. There is no question about it. Nothing is allowed in Saudi Arabia without UL. So talking about a standard, so the standard is a guideline where if you want to know the difference between a standard and an approval, we talk about codes and regulations. Code and regulations, it's a government, let's say, decision where they enforce all standards, and these standards must be checked by 100% agreed on laboratory as per Saudi Building Code, which is the UL. Clear? So what do we do for us? How do we recommend the right material? If we talk about penetrations, through penetrations, we ask normally the 100% technical questions. What is the base material? Is it concrete? Is it block? Is it drywall? And how thick it is? Yeah? We talk about the size of penetrant. We talk about what type of penetrant we have. Is it a cable? Because you know material is different. We talk about combustible material and we talk about non-combustible material. So looking at the combustible material and even the aluminum included, it's about 10 minutes for the whole material to melt under fire. So am I gonna use for PVC the same material I'm gonna use for metal? Definitely not. And when we talk about expansion joints, as engineers, architects, we also need to ask the other questions because the product and the system will work as dual. It will work as fire stopping. And if it is expansion joint, it has to take the movement. And it also has to, we have to know how much is the movement because you know, as architects, how we calculate movement in concrete. And if the base material is concrete or steel, we talk about steel about 20% more than concrete as thermal coefficient expansion. So lots of questions we as engineering, as technical expertise in Hiliti, we do ask to make sure that we recommend the right product. So as I told you, it's not something traditional where we go ask somebody and he tells you, yeah, just take this product and apply it. This is exactly what we talk about. This is a wall. We have a penetrant passing, maybe it's a pipe. And the question is, what do we do around the pipe? Because this is the weak point. This is where the fire will break through. This is where the smoke and water. So whether it's in a wall or in a roof, we have to make sure that we seal these openings with the right system. So what you see in red here is the product, and inside you see a rock wall, special properties, specifications, where density is about 64 kilograms per cubic meter, and we talk about temperature resistance of almost 1,200 degrees under fire. So very high resistance on it. This is again, in terms of designing, we talk about two things. We talk about fire rating and we talk about temperature rating. So what does a fire rating mean? We say that this system is 2 hours fire rated, meaning that if a fire breaks in this room, let's say this is a hotel, if a fire breaks here in this room, it will take 2 hours to break through these red walls. So this is what we talk about fire rated. And T rating, as temperature rating, we talk about the temperature that breaks through to the other part of the room up to 160 degrees, let's say Celsius. This is the time when the temperature transfers from the fire room to the other room. And this is really important for us because most of the material we store, it ignites at special degree. And we have to look at it. We do not look at it as, let's say, fire rating, but T rating is not as important as fire rating. So we spoke earlier about how long does it take for material to melt under fire. This is a temperature curve versus time. So almost up to 100 to 1,300 degrees Fahrenheit, 10 minutes it takes for material to melt. So we talk about aluminum. It's 640 degrees. Exactly in 10 minutes it will melt. And we talk about 600 degrees for insulation, and PVC pipes normally at 211 degrees. It melts. So this is very important. We know what material we have in the building. Why is the American standard is better than the European, is better than the DIN, or it's better than the Canadian one? Because in the American one, we talk about stream hose test. So what does this mean? It means that when the civil defense comes in to put the fire off, they are using the hose stream test with jet, with water jet. So we need to make sure that such a penetration of fire rated system, it will stay in place for the duration of fire integrity. So if we design it for 2 hours, under the pressure test, it will stay in place for 2 hours. Otherwise, it fails. The American one do test for this one, but others, they do not test. That's why the UL, when I said at the beginning of the lecture, UL is approved 100% in Saudi Arabia due to technical properties. So what do we do in Hilti as experienced people, more than 35 years in fire stopping material? And before we send our material for approval in the UL, we do internal testing. So we have a furnace, and the internal, we show you the test now in a video. And after the test, we bring the stream hose test. And if you see openings, the light through, 1, 2, 3, this means that these 3 penetrations, they failed. And these 2 only passed. So if we didn't test on the stream hose test, all material will pass. The European will pass, but the Americans stop the failure. So let me ask you a question. Talking about the base material, what have you seen? Did you see a concrete or what did you see? Is it concrete? Because you saw when he put the stream hose test, one part did fall down. So it's gypsum boards. So the test was conducted on gypsum boards, the drywall. يعني تبعين الديكور اللي بيجوا, they make some partitions. It's gypsum board 1.2 centimeter thick, each board from each side to 10 centimeters. And this is the drywall. So the test what you have seen on a drywall, and this is, let's say, the weakest, the most critical. And the hose stream test, part of it did fail, but it did stay in place 100% during the duration of fire. So we have different base materials. We talk about drywalls, and we talk about concrete, masonry, and probably we have some other, let's say, glass partitions. We have also to take care of it. How do we certify our material? Because we talk about a system that has to be approved, certified. Now, when we design our material home in our factory, we do make sure that the properties of chemical properties for the product or mechanical properties that fits 100% the demand for fire rating material. Because the education of our people, they know 100% what type of ingredients we have to have a silicone-based material or an acrylic-based material to make sure it's 100% fire rated. So we take this material with our data sheet, submit it to the UL laboratory in the States, and they immediately put the sticker if it fits. Then we go to the standards. So we talk about a penetration. Let's say we want to test this product for PVC penetration for 2, 3, 4 hours. So they 100% look at the standard, which ASTM number they have to test accordingly. So they conduct the test. Once they conduct the test successfully, they issue a certificate. So this is the final journey for us. Once you have this certificate from UL, then you as an architect, engineer, electrical, mechanical, can take this code in the design stage and put a cable tray 30 centimeter with an opening of 40 centimeter as per this code must be used. So you are telling the contractor, the engineers, once they start casting the wall, to leave openings for cable trays, ducts, according to this plan. This is what it means. So end of the day, the UL will give you a method statement certificate. You will do nothing. And the method statement, the man in the job site, engineer, supervisor, he will take it and he will implement 100%. It tells you 3 cable trays. It tells you the opening size. It tells you what material to fill in between, as per design. And this is the beauty once you go proactively. But if you do not do it proactively, and I will use one example in Saudi Arabia, I'm not criticizing, but still Saudi Arabia is far better than some European countries, for your information. Because what I didn't tell you about Greenfield Tower, that London, UK, as per hearing of their parliament, I heard it myself, they tested more than 80 towers in the UK after that accident. More than 70 towers they failed. So the example I use in Saudi Arabia, we have 285 operating hospitals. Last year it's tested. Who can tell me how many passed? How many hospitals passed in Saudi Arabia? Unfortunately, 10. Unfortunately, 10. Now a big budget is going on and a big workshop consultancy is going on, and we are part of it as Hiliti. We are proud to tell you that we are part of it. And now the cost and the time that will take to go back on such buildings and to make sure that they are fire safe, it's unimaginable. That's why engineers, it's better to go 100% safe from the beginning. This is again, just we will not spend through on it. When you look for the, let's say for the code, for the UL code, we have a designation. Then you know what this designation means, the type of material, whether it's, let's say, a joint or a PVC pipe or whatsoever. So I do not need to spend time on it, but this will guide you as an engineer. Later on, we can come, Ahmad, in a special session, a workshop in the future. If we have a plan with you, we can implement it. But this tells you exactly how to search in the UL library, in the 6,800 certificates we have. This is another UL approval. It shows you irregular one. Also, it was tested, so we can show you. Again, how to search in the UL website. Yeah. And the difference between UL and BS, as we said. Yeah. This is fairness. This is okay. Hose stream test, where the BS doesn't have. This is the main difference. Now we will go to our products, and we have some samples. Ahmed, Mahmoud, we can show, please. So what are the main applications we need to worry about? Are we, Dr. Hassa, are we having shortage on time? 10 minutes, okay. So the main applications we have, we talk about joint applications. Joint application can be a construction joint and can be an expansion joint. So you all know what a joint is in concrete. So we want to make sure if it is a corrugated sheet as composite structure, top of the wall or wall to wall, 100% we have a system. And Dr. Hassa, this is the most dangerous one we have. يعطيك العافية. I'm talking to everybody though, and this is what we talk about, the glazed and the facade joint. Talking about penetrations through penetrations, combustible pipes, non-combustibles, cable trays, floor penetrations and wall penetrations. So for the joints, we have different products. It depends, for example, on the movement. If we have plus minus 12% movement, then we go to low flexibility. If we have more, we go up to 25% plus minus. Now for, let's say, CAPSARC project designed by Zaha Hadid, we had to make a big engineering judgment on a 50 centimeter joint between steel and the slab. So that was a coating material, water acrylic base, where the movement goes plus minus 50%. And talking about through penetrations, we have, of course, intumescent mastic material. We will show you a video what we mean by intumescent mastic. In case a PVC melts, so we have to have a material that reacts quickly to temperature, not fire. So the volume of the material will expand to 7 times its original volume to make sure it's closed. We talk about different specifications and different mortar material, okay, jackets. And this is a curtain wall application, a facade joint for the glass walls. Okay, more details on the acrylic and on a silicone base, because you know as chemical we have different properties on it.
Here,
let's have a test on the joint.
After curing completely, is administered to the 500 cycles. This particular test here shows, similar to our UL listing, the 50% compression and extension.
This is composite structure. حديد خرساني بعدين جدران.
How well the material is adhering to the underside of the metal deck and the gypsum.
Okay, so this shows you the movement of a capability plus minus 50% if you have a big gap. This is the most important one where unfortunately everybody fails. And we talk about the aluminum over here and the glass. This is the side wall. And we talk about this joint between the slab and here. Now, the UL system says that the spandrel, and this is what we mean by spandrel, a minimum of 1 meter above the slab and 1 meter below the slab has to be fully insulated with rock wool. Why? Because at the beginning we said 600 degrees, the aluminum will melt. So if I'm sitting in one floor and the aluminum melts on the side, so it will travel outside to the second floor. We have to make sure that when fire breaks through the glass, it will not go to the upper floor or the below floor. Now, UL demands this, other they do not do. And I urge the architects, because architects, when they design buildings, the owner will say, I want a view. Yani if I sit here on the edge, I want to see the street. I don't want to have something to block my vision. Now, you have to choose between view and between safety. Go for safety. This is again, as per UL, this is the detail, okay? More applications we talk about. So the message over here, let's not spend more time on it. So if you have penetrations for pipes, let's say, yeah, metal pipes, we have different material. That's what I said at the beginning, not one product for all, depending on the property of the material itself as penetrant. we recommend the material. So this is acrylic base. Intumescent mastic base, if a pipe diameter is less than 3 inches, if above 3 inches, we have more expandable material to fill the voids. And again, we talk about ducts. Ducts are 2 types, insulated duct and non-insulated. So the insulated, we deal with it as intumescent, as PVC. The non-insulated, we deal with it as, okay, metal part. Talking about cable trays, different sizes. We have small size, we have medium size, and we have bigger size. So depending on the plan, as electrical engineers, we go ahead and recommend the right product based on the size. This is another product we just brought recently, where you can close big gaps with multi-penetrations in it. Please see this video, what happens in PVC pipe under fire. This is the fire stop device. Now material started to expand. So 6 minutes exactly, the whole PVC is gone. For 2 hours we tested this. Look at the other side now. So this is exactly what we talk about, containment of fire and compartmentation, to make sure no smoke, no fire, no water will go to the other part. End of the day, we have the product, then we have a system, then we have the technical engineer, architects, hopefully you in the future, and we have the design proactively, and everything is done. But what is the most important piece that we need to carry is the execution. Who will install this? Is it a normal, let's say, laborers we have in job sites? Unfortunately, this is what's happening, because there is no enforcement that a third certified party will do. So before you say this building is 100% safe, we have to make sure that we inspect it. So inspections come visual. We make sure that everything as per plan, everything as per specification, the right material, the right color, and we have tags put in. And destructive, for example, to come to 10% of the material we applied, and we cut, we make sure that we have the right material, depth, and so on. Yeah? And we of course bring our plans that we did as engineers, and we check thoroughly through that it fits 100% as per UL. This is a documentation software. Please have a look at it, and it will be our final piece. So what you have seen over here, we did everything. And what happens tomorrow when you give the building to somebody so they can operate it and people live in it? You need to document everything that you did. As engineer, we talk about BIM, and we talk about, let's say, rivets, and we talk about 100% as-made drawings. So this guarantees that our material will work for 30 years. So 30 years, if a fire breaks through, the material will do. So end of the day, we have the products applied on a penetration, and we have a barcode, and you can anytime come, scan this barcode, you go to your computer, it gives you the whole history. It gives you what type of material, what type of specification, who's the consultant, who's the contractor, and when it was applied, and if you sell the building, it will be sold with it. Okay, this is our session today, and it's open now for questions if you want to have. We can spend more time, but due to your time, we stop right here. So thank you very much. Any questions? Please.
How do you deal with opening in terms of doors? And how you block the fire?
You're talking about the floors or doors, did I hear it? Doors. Now doors, you need to go to a special manufacturer. This is not, let's say, scope of work of Hilti. And every trade, every segment we have in the market, he is 100% aware that there is a fire-rated doors. So the door must be manufactured accordingly, and it must be certified also UL, that this type of door and this factory has passed the UL, and please go with it. And if you need 2 hours, 3 hours, 4 hours, they will provide you with a door 100% that fits. Very good question. Others, please. Sabaya. Come on. Okay, this means 2 things. Either they understood it 100%. I'm sure you did. So I'm very happy to be here today. Really, thank you very much. Very exciting. Thank you. Thank you. Okay. Of course. Of course. Now, our program with the university is not stopping here. We can exactly tell you what we are planning, let's say, to contribute on 2030 vision for Saudi Arabia. This is our part, and we will pay it gladly, free of charge. Thank you.